Graph Theory Class 8 Video 1. In this video we're going to talk about special graphs. Special graphs are just graphs that come up so often in the study of graph theory that people decided to give them their own names. Okay, so let's begin with the definition of the first type of special graph. And this is called a complete graph. So a complete graph is a graph where every pair of vertices is connected by an edge. Okay, that's the definition. So every single pair of vertices, there's exactly one edge connecting them. And we tend to think about complete graphs as undirected and unweighted, but you can also talk about directed and weighted complete graphs. But by default, if I say complete graph, I mean undirected and unweighted. Okay? And the notation we use to denote a complete graph is k subscript n. So this means the complete graph on n vertices. The complete graph on n vertices, where n is a number. Okay? So the complete graph, it isn't just one graph, it's a different graph for every n. So if you give me an n, there's a complete graph on n vertices. So let's just start, so simple it's almost stupid. Let's start with k1. Okay? So this is the complete graph on one vertice. So by definition, there's an edge between every pair of vertices. Well, there is no pair of vertices. There's only one vertex. So that's the complete graph on k1. Okay, I told you it was a bit stupid. Let's do k2. So now, let's just make sure I separate these things. k2. So now I draw two vertices, and there's an edge between every pair. So I just draw an edge, like that. Okay? Let's draw k3. So I draw three vertices, and between every pair I draw an edge, like that. Okay, easy enough. Lastly, let's do k4. So I draw four vertices, and I fit an edge between every single pair. So it's like that. I can't fit any more edges in. Okay? And as you can see, when you increase the number of vertices, when you increase this n number, the graphs get more and more complex. Okay? So they get a bit more annoying to draw. So instead of drawing them, I'll just show you this is what they look like. So we have k3, k4, k5, k6, and k7. And it goes on and on and on, but you imagine, they just get more complex to draw. The idea is you have vertices and edges between every pair. Okay? And this is an important type of graph. This type of graph comes up a lot. It comes up again and again and again. This is the complete graph on n vertices. So let's move on to the second type of graph that I wanted to talk about. This time it's called a cyclic graph. So a graph that consists of exactly one circuit with no repeated vertices is called a cyclic graph, or sometimes you just call it a cycle. Okay? And the notation we use to denote this is Cn. So n, again, is a number. It tells you how many vertices you have, and Cn is the cyclic graph on n vertices. So let's try and work out what these things look like. C1, well, C1's sort of like a dumb case. It doesn't exist. Does not exist. I mean, if you think about it, it's impossible to draw a cycle, a circuit with just one vertex. Similarly, C2 does not exist. Okay? But C3 actually exists. You draw three vertices and you just draw a circuit. So a loop. Okay? That's C3. And C4 also exists. C4, you draw four vertices and you draw a loop. Like that. Okay? So let's look at some higher vertex examples. So we have C3, C4, C5, C6, and C7. So cyclic graphs are easier to understand than complete graphs. Okay, there are fewer edges in cyclic graphs. These are the cyclic graphs, and it keeps going. It doesn't stop at 7, obviously. Like, you can make a cyclic graph as big as you want. Okay. Before I finish the video, I just want to note something which you might have already noticed. Sometimes these special families of graphs, they're not always perfectly disjoint. Like, you might have noticed that K3 is actually equal to C3. Okay, K3, if you recall, is like this, and so is C3. And that's perfectly fine. It's just a coincidence that these two graphs happen to be equal. Okay. One more thing I want to note is when I'm talking about these special graphs, I'm talking about them up to isomorphism. So if I say something like C4, well, this graph here, if I could draw, is still C4 because it's isomorphic to this one here. They're isomorphic, so I still count this as C4. Okay? These names, the cyclic, you're talking about the isomorphism class of the graph. Okay? That's the end of this video.